Hello engineers, welcome to the new video of the course, and in this particular video we are going to see the fourth property or the fourth characteristic of semiconductor, that is this one. It states that semiconductor only allows unidirectional flow of current. What is unidirectional? That means semiconductor device allows the current to flow only in one direction. Okay, so we are going to understand this particular concept in detail way. So for that, let me go to this particular slide. Yeah, so what I had done over here is that, see, let me first write over here, what is this brown color box? You can clearly see this one. What is this? This is my conductor. Okay, this is my conductor. What is conductor? Conductor is a device which can actually pass current through it, current and heat through it. Okay, great. So for time being, we will assume this particular conductor to be like it is made up of iron. If you want, you can also assume that it is made up of copper. Okay, so for time being, I'm assuming that my conductor is made up of iron material, that is Fe. Okay, Fe means iron, right? Similarly, this is my conductor. Again, it is made up of iron material, Fe, right? If you want, as I mentioned, if you want, you can also take copper, aluminum. It's up to you. A good metal, you can take any good metal which you can take any metal which is a good conductor of electricity. Okay, great. So now what I'm doing over here is that I'm directly supplying 5 volts to this particular conductor, but you just see the direction of the voltage source. Okay, so over here what I'm doing is that I'm providing positive voltage to the A side of the conductor, to the A point, and negative voltage to the B point. Okay, and in the second case, what I'm doing, I'm providing negative voltage to the A point of the conductor and positive voltage to the B point, right? So basically I'm reversing the voltage source in both of this particular scenario, but my conductor is same. I'm assuming that my length, my area, and my material of the conductor, it is all of this property of the conductor, they both are same. They all are same, not both are, sorry, they all are same. The area, length, even the material of conductor, everything is similar. Just the thing is that I'm reversing the voltage source over here. So it's my question to you all guys, what exactly will happen in both of this particular scenario? Just pause this video and try to think in your mind. Alright, I believe that you might have tried your best to think upon this particular concept. Now let me just give you the answer. So the answer is very, very simple. You see over here, in this particular scenario, since we all know that conductor is good, conductor can actually pass electricity. So basically this is the this will act as a good conductor, right? Since we are taking iron, so iron is a good conductor of electricity. So obviously a current is going to flow, but in which direction? We all know that current always flows from positive to negative. So in this particular case, the current is going to flow in this particular direction. So let's assume that my current I, it is flowing in this particular direction. Okay, great. Now let's come to this particular case. Again, over here we all know that this particular conductor, it is made up of iron. Okay, so it will pass current. So basically a current is going to pass through it, right? Or it will pass the current through it, right? So but this time, if you look very clearly, my positive terminal, it is present below, and the negative terminal, it is present above, right? Something like this. So what is going to happen in this particular scenario? We all know that current always flows from positive to negative. So in this particular scenario, the current will flow in this particular way. So you can clearly see that my conductor, or rather a conductor, can pass a current in both of the direction. It will pass the current in this direction as well, and it can pass the current in this direction as well, right? Great. So now we are going to see it in the on the Tinkercad software. Okay, because when we simulate it, then it would be pretty easier for us to understand this particular concept. Okay, now coming to this particular point, see, I'm considering a resistor of around 10 ohms. Okay, why I'm considering a resistor of 10 ohms? Because on Tinkercad software and in any other circuit simulation software, you don't have a privilege to connect a conductor directly. Okay, you don't have a privilege to connect a conductor directly if you are connecting a wire, right? If you are shorting it, so basically the software won't provide you certain resistance, because obviously this all of these particular circuits, they are assumed to be ideal. What is meaning of ideal? That means this wire has zero resistance. Okay, but if you try to do your experiments in the labs, so this particular wire, it might have certain resistance, maybe 1 ohm, 2 ohms, 3 ohms. Okay, but in softwares, you won't get any resistance, or rather wire won't drop any voltage across it. Okay, Okay, and the second thing is that even if you see over here in the component section, we don't have a privilege to select a conductor over here, or rather they had not mentioned any conductor over here. So that's why I had connected a resistor of 10 ohms, okay, in place of this particular conductor. Okay, so instead of conductor I am placing resistor over here. Okay, and why I am taking 10 ohms? So for that, let's come over here, and you can clearly see resistance of iron and copper, it is roughly around, although it depends on length and area and all, but if I consider maybe a length of around 1 meter or so, and if I'm operating my experiment, or rather if I'm performing my experiment at room temperature, so it can provide me a resistance of around 3 to 5 ohms. Okay, 3 to 5 ohms. So that's why I had considered it. I mean, I had considered 10 ohm of resistance. Okay, which is quite closer to it. Okay, great. And I'm providing 5 volts. Okay, so now let's run this particular simulation. Alright, and you can clearly see a current of 500 milliamperes. It is flowing through it, right? So basically my current is moving in this particular direction. Just a second, let me just show it to you, so that it would be pretty easier for you all guys to understand this particular concept. See, this is the positive terminal. See, this is the positive terminal, and this is the negative terminal. So this is the, let me erase this. Just a second. Yeah, so this is the positive terminal and this is the negative terminal, and as I mentioned, my current should always flow from positive to negative. So it will flow in this particular direction. It will come over here, it will go in the multimeter, and it will then flow in this particular direction. So you see my current, it is flowing from this particular direction. See, from here to here. So this is my point A and this is my point B. Great. I hope you are able to understand this. It will follow this particular direction and it will return over here. Okay, so this is the direction in which my current will flow. Great. So now let me erase all of the thing. If you want, you can take screenshot of it. I'll just pause just a second. Yeah, I hope you all guys might have taken a screenshot of it. Now let me erase all of the thing. Great. Now what I'm going to do is that, see, I'll just click on this particular wire and I will just move this particular wire to the, just a second. Yeah, I will click on this wire and I will just move this particular wire to, just a second, why it is not moving, just a second. Oops, just a second, let me just stop the simulation. Yeah, alright, so now what I will do over here is that I'll just click on the wire and I will move this particular wire to the negative terminal, and then I will click on this particular wire and I will move this particular wire to the positive terminal. Let me arrange it properly. I'll explain you, don't worry what I'm doing over here. Alright, so if you look very clearly, now this time what I'm doing over here is this. See, this time I'm providing positive voltage to the B point and negative voltage to the A point. If you look very clearly, this is my B point, and to the point B I'm providing positive voltage, and to the point A I'm providing negative voltage, right? And in between I had connected the ampere, okay, ammeter I would say, and sorry, not ampere, in between I had connected ammeter. Okay, so now let me just run this particular circuit. Sorry, let me just run it. Yeah, and you can clearly see this time it is showing minus 500 milliampere. Why? Because if you look very clearly, this time the current is flowing in this particular direction. In this particular direction it will flow in this way, right? Now this time the current will flow from B to A, right? It will flow over here and then it will come out from this particular ammeter. It will flow in this particular direction and then it will move in this particular power supply, right? So this is the flow of current, or rather this is the direction of the current. Okay, great. So just take a screenshot of it. Alright, I believe that you might have taken the screenshot of it. Now let me erase it. Just a second, let me erase all of the things. And now what I'm going to do over here is that instead of resistor I'm going to connect a diode. Okay, so but before that let me stop the simulation. Yeah, instead of resistor I'm going to connect the diode. So let me delete it. Yeah, and now let me just connect the diode. Where is that diode? Just a moment, let me just search it. Yeah, somewhere over here. Yeah, so this is my diode. Let me erase the wires as well, delete the wires as well, sorry. Yeah, so now what I'm going to do, I'm going to connect the positive terminal of this power supply to the multimeter, to the positive terminal of multimeter, and a negative terminal of multimeter, although I had set the multimeter on ammeter, right? If you look very clearly, I had set it on ammeter. Basically I'm measuring current, right? And I'm going to connect the negative terminal of diode to the negative terminal of power supply. Don't worry, I'll explain you. So let me go to the next slide over here. Yeah, okay. So now if you look over here, what I'm going to do, so if you look over here, the circuit is similar, right? Just the thing is that instead of conductor, over here I was using conductor, right? Over here I was using conductor. This time I'm using a semiconductor. Okay, this time I'm using a semiconductor device. Okay, I'm using a semiconductor device. So this is my semiconductor. So this is my semiconductor device, right? For time being we will assume it as diode. Okay, so this is my diode, and even this is my diode. Okay, so for time being we will assume it as diode. Great. So let me just explain you what that line states. Okay, so if you look over here, what I had written is this, that is a semiconductor only allows unidirectional flow of current. Okay, what does that means? That means if you look very clearly, in case of conductor, so what conductor was doing, the conductor was allowing the current to flow in both of the directions. So my current was able to flow in this particular direction as well, and my current was able to flow in this particular direction as well, right? But in case of semiconductor, the semiconductor device will only allow the flow of current in one direction. So either my current will flow in this particular direction, or else my current will flow in this particular direction, right? Okay, it depends on the device and the polarity of the device as well. Okay, I know it might find it little, you might find it little difficult to comprehend, but don't worry, I will explain you. So now what I'm going to do over here is that to the positive terminal of the voltage source, I'm connecting the this p-type region, or the positive terminal of diode. Okay, so let me just show it to you over here. So this is my diode. For time being, let's assume that this is my diode. As I had already mentioned, that the triangular shape, assume it to be positive. So this is my p-type region, and this is my n-type region, right? So if you are not aware of p-type and n-type region, don't worry, you can consider it as positive terminal of diode, and n-type as negative terminal of diode. Okay, alright. So basically if you look over here, I'm providing a positive voltage to the p-type region and negative voltage to the n-type region, right? And I had already mentioned that this is my, see this particular white color line. Okay, white color line indicates that this is my n-type region, or rather this is my negative terminal of diode, and this is my p-type region, or the positive terminal of diode. Great. So let me erase this. Yeah, so now what is going to happen? You'll see that. So let me just select this. Yeah, so now let me run this particular simulation, and let's check if you are getting current, right? If you are getting current, that means my diode will act as a closed switch. That means what? My diode will allow the current to flow, right? If at all we are getting certain value for current, because we had set it on ammeter, right? So let me just run this particular simulation. Alright, and you can clearly see we are getting a current of around 5 amperes. Okay, so we are getting a current of 5 amperes. So let me just write over here. Okay, so in this particular circuit, as I mentioned, that we are connecting p-type to the positive terminal and n-type to the negative terminal. So basically we are getting a current of 5 ampere. We are getting a current of 5 ampere. Okay, great. Now as I had already mentioned that a semiconductor will only allow unidirectional flow of current. That means what? We won't be able to get current in this particular scenario. So in this particular scenario, I should get current of 0 ampere. Okay, again I will repeat. What does this point state? The point states that semiconductor, see over here, semiconductor only allows unidirectional flow of current. Okay, and right now we had simulated, we had simulated this particular circuit, right? As I had mentioned over here as well. See, this is my p-type, just a second. This is my p-type and this is my n-type, right? this is positive, this is negative. Similarly, this is my N type, this is my P type. This is negative, this is positive, right? Great. So if you look over here, what I'm going to do, I'm providing positive voltage to the P side and negative voltage to the N side, right? Great. So during this scenario, we are getting a current of 5 ampere. Let me just write over here. During this particular scenario, I'm getting a current of 5 ampere. Okay, now we will move to the next scenario. What I'm doing, I'm providing positive voltage to the N side. I'm providing positive voltage to the N side and negative voltage to the P side. Over here as well, if you look over here, providing positive voltage to the N side, I had intentionally, change the diode over here. I'm reverse the connection of diode over here. Just a second, I'll just show it to you over here. So this time, what I'm going to do, I'm going to provide negative voltage to the P side and positive voltage to the N side, something like this. So this is my N type region, this is my P type region. So basically this is my, this will act as a positive terminal of diode and negative terminal of diode. So if you look over here, I'm providing negative voltage to the positive terminal of diode and positive voltage to the negative terminal of diode. So we will check if we are able to get certain value for current. If not, that means the diode will act as a open switch, or rather it will behave as an open circuit and it won't allow the current to flow through it. Okay, if you want to look over here, I had intentionally drawn the diode in this way. Okay, if you look very clearly over here, I had interchanged the connection of the voltage source, but over here I had interchanged the connection of diode. Okay, don't worry, I know you all guys are not that much familiar with diodes, but still try to understand this particular concept. Don't try to simulate. Okay, so let me go to that particular simulation software. Just a second. So sorry, let me go to this particular simulation software, and now let me stop the simulation and let me just interchange the wire. So this time I will just connect this wire over here and this particular wire over here. Okay, just a second. Yeah, somewhere over here and somewhere over here. So if you look very clearly, I'm connecting the positive terminal. So this is my plus and minus 5 volts. So I'm connecting the positive terminal of the voltage source to the N type region, or you can consider it as negative terminal of diode. And if you look over here, negative terminal of a voltage source to the P type region, or you can consider it as positive terminal of diode. Okay, and let's see if we are able to get certain current or not. Okay, so for that, let me just simulate this particular circuit. Alright, so you can clearly see that the value of current is straight away 0. The value of current, it is straight away 0. So this time my I is equivalent to 0 ampere. Okay, whereas in previous scenario, my I was 5 amperes, right? Okay, in the previous scenario, but in this particular scenario, my current is straight away 0. So this particular condition, it is getting satisfied that the conductor allows bidirectional flow of current, but semiconductor only allows unidirectional flow of current. Meaning is that it will either allow the current to flow in this particular direction or else in this direction. Okay, great. So I believe that you understood this particular concept in depth, but still if you have any doubts, if you are facing any difficulties anywhere, it's my request to you, please ask me in the communication section. I will surely help you out there. So thank you for listening me patiently. I'm ending this video over here. Thank you.